All right, so let's consider this integral here. Integral 0 to 2 of x cubed over cube root of x to the fourth minus 1. This one here is undefined when the stuff at the bottom is 0. X to the fourth minus 1 will be 0, particularly when x is equal to 1, which is a part of this integral. So we actually have an asymptote occurring at x equals 1. So what that means is we're going to actually work this out as two separate integrals. The integral 0 to 1 of that expression plus the integral from 1 to 2 of that integral. So with that in mind, since I'm going to have to do two integrals here, I'm going to go ahead and work out the integral first, get its antiderivative, and then we'll work on our two pieces. And so just working on the integral of x cubed over, actually we don't even need to write it as over, we'll just do it all together here, as x cubed out front times x to the fourth minus 1 to the negative 1/3 dx. And then we recognize we can let u be the inside part, x to the fourth minus 1. Du commands us to have a 4x cubed to go with our dx. Fortunately, we have what we need, so we bring the 1/4 out. We'll have integral of that stuff to the minus 1/3, and we'll have our 4x cubed dx. So that we have the integral of u to the minus 1/3 du, u to the minus 1/3 du. So that'll just carry through, add 1 to the exponent, which will make that 2/3. When we divide by 2/3, that's the same as multiplying by 3/2. U, which is x to the fourth minus 1 to the 2/3 power, plus our constant. So in the end, we're going to have 3/8 times x to the fourth minus 1 to the 2/3 plus a constant. All right, so we've worked the integral out, and now we're ready to talk about the two pieces from 0 to 1. So let's work that out, and then from 1 to 2. So from 0 to 1, that would be the limit as b approaches 1 from the left of all of this stuff. 3/8 x to the fourth minus 1 to the 2/3, evaluated between 0 and b, b being the upper limit in this case. Okay. So we work that out. It's going to be limit as b approaches 1 from below of 3/8 times, when we plug b in, that's going to be b to the fourth. 1 to the fourth minus 1 will be all 0. 0 to the 2/3 would be 0. Okay. And then minus, and then we plug in 0. And when we plug in 0, that's going to be 3/8 times 0 minus 1, which would be minus 1 to the 2/3. Okay, so all told, actually I don't even need limit there since I already took the limit. So all told, this will just be negative 3/8. The integral from 0 to 1. And then we do the same thing. Limit as b approaches 1 from above of 3/8 x to the 4th minus 1 to the 2/3, evaluated between 1 and 2. So when you plug in 2, that's going to be 2 to the 4th, 16 minus 1. So we're going to have 3/8 times 15 to the 2/3. And then when we plug in the 1 in the bottom there, that's again just going to evaluate to be 1 to the 4th, which is 1, minus 1, which is 0. And all that other stuff is 0. So we get 3/8 of 15 to the 2/3. And so putting it all together, we can factor out that 3/8, and we have 15 to the 2/3 minus 1. Factoring out 3/8, that's our exact answer. And then we can just approximate that as about 1.906, okay, rounding off. And so here we've done, in this case, a definite integral that actually did pass through a vertical asymptote, is what we actually ended up doing here. Here's the picture, kind of a little zoomed in here, right? And you can see we had this area here, that was the one that ended up being our negative 3/8, from 0 to 1, and then our second one from 1 over to 2. And so we actually have done an integral here across this asymptote. Because we were able to work out the two pieces, they were both finite, we were able to work out the overall integral on that function. Okay, so that was an example again of how we need to keep an eye out for, in our integrals, are we passing through an asymptote? When you're dealing with the horizontal asymptotes going to infinity, those are pretty clear because it's spelled out. But the vertical asymptotes, you just have to keep that eye out as you're doing these integrals here.